This is a short lesson to introduce the unit called the electron volt. So 1 joule is very large for working with energies of electrons and atoms, so it's helpful to have a much smaller unit. And that unit is the electron volt, which has this symbol. And the electron volt is a unit of energy, even though it sounds like it's a unit of potential because it has volt in it. Specifically, an electron volt is the energy that's gained by one electron, and the charge on an electron is the elementary charge, 1.6 times 10 to the negative 19 coulombs. An electron volt is the energy gained by one electron when it moves through a potential difference of 1 volt. So remember our equation that the change in the electric potential energy is equal to the work done on the charge, which is equal to the magnitude of the charge times the potential difference. So if our charge has magnitude 1.6 times 10 to the negative 19 coulombs, we won't worry about signs here, we're just looking for the magnitude of the energy. And the potential difference that it's moved through is 1 volt, and remember that 1 volt is equal to 1 joule per coulomb. Then just multiply and cancel the coulombs, and I get a change of units to 1.6 times 10 to the negative 19 joules. So when I move an electron of this charge through a potential difference of 1 volt, it experiences a change in energy of 1.6 times 10 to the negative 19 joules. And this is 1 electron volt. 1 electron volt is equal to 1.6 times 10 to the negative 19 joules. It's just a unit of energy. It's a much smaller unit of energy than a joule. Just like we wouldn't want to measure the time scale of molecular events in weeks, months, or years, we don't want to have to measure their energies in a large unit like a joule. So an electron volt is just a much smaller unit. Just keep in mind that it's a unit of energy, not a unit of potential, and you won't let yourself get confused. So that's the electron volt.